All right. So in 8.7, we're looking at just an application of the trigonometry applications. So sine, cosine, tangent, all those things are going to come into play here. We're going to find angles. We're going to find sides. A couple of things to look at here. There's two vocabulary words, angle of depression and elevation. And um, the the directions of them or the description of them doesn't exactly make sense unless you're looking at a picture. In your textbook, there is a picture for this lesson, and it looks something like this. Um, so an angle of elevation is if I'm the person on this boat and I'm looking horizontally, the angle of elevation would be something where if I had to raise my eyesight up to see something above me. So pretending there's someone at the top of this lighthouse, if I were to make eye contact with the person at the boat, I would have to look up. And if I was someone looking at the from the lighthouse, I would have to look horizontally. I would never even see the boat if I was looking across. But if I lowered my vision, that would be the depression piece. I would lower my vision down to meet. You'll notice that the two horizontal lines are parallel. We have a transversal, so the angle of elevation can also be the angle of depression. And so when we start to fill in our triangles and the information there, we'll be looking at those angles to be congruent always. So an example here that we'll take a look at is if a plane is flying at 30,000 feet of elevation. So we have our right angle created by the ground and then the straight line up to the plane. The question says, what is the angle of descent that will allow the plane to arrive safely? So the idea is if the plane was just going to continue to fly, it would fly in a horizontal fashion. It would have to adjust its angle to my bad. It would have to adjust its angle to something there to make it start to descend down towards the airport. So at 100 miles and 30,000 feet. So the plane right now is 100 ground miles away from the airport. So the first thing we're going to look to do is obviously we have two different units. So the first thing we're going to do is we're going to figure out that there are 5,280 feet in 1 mile. Therefore, 528,000 feet are going to be traveled across the ground. So now we have our two dimensions set up, and we can then use our angle of elevation as the same thing. And so now we have our alternate interior angles. This is going to be our x. Okay, so the ratio we would use, we're looking at the opposite side and the adjacent side. We're going to use tangent there. So with the tangent ratio of x, we're looking at the fraction of opposite over adjacent. So 30,000 divided by 528,000 gives you a decimal. And then from there, we're going to convert that decimal into from the table into a degree measurement. And that degree measurement is about 3.3 degrees. Now, I rounded to the nearest tenth. It was actually 3.25 or something like that. So if we're rounding it to the nearest whole degree, which we typically do, then 3.3 degrees would be the degree measurement there. Next, what if we knew the angle of descent, but now we're trying to figure out how far will the plane actually fly in the air? And notice it says, what is the air distance? Air distance is this dotted line right here, this dashed line. So people get confused with air distance, and before I said ground distance. So air distance is how far will the plane fly in the air. So that's the hypotenuse. And given the fact that it is a angle of descent of 4 degrees. Same elevation, so it's still 30,000 feet in the air. We're going to do the sine ratio this time of 4 degrees, and then opposite and hypotenuse, we're solving for that. So using the proportion, I'm just going to switch the x and the sine of 4, and I'm going to divide 30,000 by the sine of 4 degrees. When I do that, I find that it is approximately 430,000 feet. And when I convert that by dividing by 5,280, I find that the plane will fly approximately 81.5 miles in the air to get to the airport. Last example. Percent grade is a topic that we've brought up before for different reasons, and I had mentioned that it was going to come up again. Percent grade is simply just rise over run. So if I wanted to write the word percent, the percent as a fraction, it would be 20 over 100. Well, if we think about rise over run as a triangle, making it a right angle, we have this would be 20. Sorry, I'm using my mouse here. And this would be 100. So from there, I can use the tangent ratio to figure out, well, what is this angle right here? What is the angle of elevation that the road would be, or what would be, in this case, the angle of depression if the car was going to go straight across? So have that answer ready. What is this angle right here for the 20% grade of the road? And enter that in the form when you finish it.